Picture this, a future where everything you know slows down, fades away, and eventually, stops. Not in a dramatic, fiery explosion, but in a quiet, unhurried drift toward eternal stillness. That's the big freeze in a nutshell, a scenario where the universe continues expanding, and as it does, galaxies grow colder, stars burn out one by one, and we're left with an infinite expanse of darkness and ice. Every source of heat, every flicker of life, and even the atoms that make up your very existence would settle into a state of complete inertia. Can you imagine it? A universe stripped of energy, motion, and meaning, a frozen silence stretching on forever. Here's the thing, though, this isn't something that's on the calendar for next week or even next year. The Big Freeze is a process playing out over trillions of years, time so vast it's nearly impossible for the human mind to grasp. To make sense of it, think of it like an hourglass. Right now, stars are the sand at the top, shining brightly, but with every passing moment, they're trickling down, burning through finite fuel until nothing is left. Every galaxy, every planet, even the very fabric of existence will lose its warmth. It's almost poetic, in a way, a universe that once began with unimaginable heat and chaos eventually winding down to a whisper, a faint echo of what once was. But doesn't that make you wonder, what does this mean for us, right here and right now? Think about it. If the universe itself, with all its vast galaxies and endless wonders, is destined to fizzle out, what does that say about the time we have? Maybe it's a lesson, to stop postponing the meaningful things in our short lives, to use our own heat while we still can. We are made of the same stardust that will one day scatter cold and lifeless, but today, we burn bright. It's a humbling thought, and maybe a little unsettling, but don't get too comfortable just yet. After all, there's another possibility for the universe's end, and it's far more dramatic. Ready to hear about the Big Rip? Now, let's dive into a scenario that's far less calm and infinitely more unsettling, the Big Rip. Imagine a universe where the expansion we currently see, yes, the one that's spreading galaxies apart, doesn't just continue, but accelerates to a breaking point. In this reality, even the most stable structures of existence, like galaxies, stars, and planets, won't survive. Everything, down to the very fabric of space itself, will eventually be torn apart. Sounds dramatic, doesn't it? But that's the essence of the Big Rip, an eventual fate where nothing, not even the tiniest atoms, could escape the relentless pull of this cosmic expansion. To put this into perspective, think about gravity as the glue that holds the universe together. It keeps planets orbiting stars, stars clustering in galaxies, and even atoms maintaining their structure. But what happens when the force driving the expansion of the universe, something we call dark energy, outpaces gravity itself? At first, galaxies would drift apart, like boats on a slowly widening ocean. Then, stars would get ripped from their systems, planets from their orbits, and so on, until even molecules are broken down. It's a cosmic unraveling, one step at a time. And while it sounds like something out of a sci-fi movie, this possibility is grounded in real physics. Scary, right? But here's the fascinating part, it all ties back to dark energy. It's the mysterious force driving this expansion, and yet we barely understand it. What if this knowledge could transform not only how we look at the universe but also how we see challenges in our own lives? Imagine problems growing so rapidly, like this cosmic expansion, that solutions need to be equally adaptable, equally innovative. Just as the Big Rip forces us to question the limits of matter, maybe it nudges us to consider where in our lives we're ignoring accelerating tensions. The beauty, though, is that this is just one possible scenario of the universe's end. And believe me, the next one we'll explore is just as captivating, but in a completely different way. What if, instead of endlessly expanding, the universe decided to reverse course? That's the mind-bending premise of the Big Crunch. Imagine the galaxies, which are currently racing away from one another, suddenly stopping in their tracks and beginning to move closer together. Slowly at first, but with time, this journey inward gathers speed. This catastrophic reversal would mean that everything, galaxies, stars, planets, even the very fabric of space, is pulled back into a single, dense point. Essentially, it's like hitting rewind on the history of the universe, all the way back to its fiery beginnings. Hard to picture. Think of compression. It's as though the entire universe is being crammed into a single box too small to hold it. Now, how would this happen? The Big Crunch takes place under the idea that gravity, not dark energy, wins the ultimate cosmic tug-of-war. While dark energy is currently driving the expansion of the universe, theories suggest that if it ever weakened or reversed, the force of gravity would take control. And gravity doesn't take prisoners. Slowly but surely, it would yank galaxies back together, condense gas clouds, and ignite stars in a final, brilliant blaze before everything collapses into an unimaginable abyss. Imagine staring up at the night sky in this era. All those shimmering galaxies we admire today condensed into a monstrous, glowing mass, signaling the universe's terminal march toward destruction. It's strangely beautiful, isn't it? A cosmic finale of light and fire. But let's flip the perspective for a moment. If the universe is indeed cyclical, a pattern of expansion, collapse, and potentially rebirth, how does that change how we think about endings? Maybe the Big Crunch isn't an end, but a beginning waiting to happen. A chance for the universe to reset itself, like a phoenix rising from its ashes. In a way, it mirrors challenges in life. Even our collapses may hold within them the seeds of renewal. Still, as poetic as that sounds, the actual science behind this theory is up for debate. And speaking of debate, there's another layer to the story, one that has to do with energy and matter. What happens to them in the universe's final state? Let's dig deeper. What happens to everything, matter, energy, even time itself, when the universe reaches its ultimate fate? Well, that depends entirely on which cosmic finale plays out. Whether it's the icy stillness of the Big Freeze, the violent unraveling of the Big Rip, or the fiery implosion of the Big Crunch, one question remains constant: what's left behind? Imagine matter breaking down into its most fundamental building blocks, leaving nothing but diffuse particles scattered across an infinite void. Energy, too, would dissipate into useless heat or be trapped in a gravitational prison, unable to interact with anything. It's the ultimate end, a universe devoid of meaning, function, and structure. Take, for example, black holes. In almost every scenario, they'd play a key role in the final chapter of existence. These cosmic monsters consume matter and energy, compressing them into unimaginably dense points called singularities. Eventually, given enough time, even black holes might decay through what physicists call Hawking radiation, leaving behind nothing at all. What's left is what scientists call heat death, a state where all energy is so evenly distributed across the universe that no work, no change, no life can occur. It's like a battery drained to zero, with no hope of ever being recharged. Matter and energy, the very foundation of existence, reduced to a barren landscape of nothingness. Sobering, isn't it? But this raises an intriguing question: can anything truly end, or is transformation just another form of continuity? If matter and energy are never truly destroyed, perhaps this final state lays the groundwork for something entirely new. Think about the cycle of life. A forest fire may destroy everything in its path, but that destruction makes way for new growth. Could the universe itself operate on a similar principle? Are these ends simply transitions into unknown states we can't yet comprehend? It's a lot to ponder, but one thing is clear: no matter which direction the universe takes, energy itself holds the key. And that brings us to one last piece of the puzzle: dark energy. What role does it play in this grand cosmic drama? Let's uncover that next. Dark energy, the ultimate enigma of the cosmos. It's a force we can't see, can't touch, and barely understand, yet it's quietly shaping the destiny of the entire universe. You know how galaxies are moving away from each other at an increasing rate? Dark energy is the prime suspect behind that. It's like an unseen puppeteer pulling the strings of the universe's expansion. And here's where it gets truly mind-blowing: dark energy isn't just a passive player. Depending on how it behaves over time, it could dictate whether the universe drifts into an icy eternity, rips itself apart, or collapses back into a fiery rebirth. It's the wild card in this cosmic game. Now, let's make it relatable. Imagine you're on a speedboat heading across a vast ocean. At first, everything seems stable, the engine's humming along nicely, the waves are steady. But then, out of nowhere, a mysterious force kicks in, pushing the boat faster and faster. You lose control over the throttle, and now your entire journey depends on this wild, unpredictable energy. That's what dark energy is to the universe. If it gets stronger over time, you've got something like the Big Rip on your hands, an unstoppable acceleration tearing apart galaxies, stars, and everything in between. If it weakens, though, gravity might take over, leading to a big crunch. Or maybe it balances out, leaving the universe to freeze in place forever. The possibilities are as vast as the universe itself. But here's the kicker: we still don't know what dark energy truly is. Is it some kind of field permeating space? Are there hidden particles we haven't discovered yet? Or is it something even stranger, something that challenges the very way we understand physics? What we do know is that it accounts for roughly 70% of the universe. That's right, most of existence is dominated by something we can't even fully comprehend. So, what does that mean for us? Maybe it's a humbling reminder that some mysteries are meant to stretch our imagination, to remind us that the universe, and our existence within it, is far from ordinary. But speaking of mysteries, have you ever wondered, Junior, how everything we've discussed ties into the ultimate endgame? Let's wrap it all up. Have you ever stopped to wonder, not just how the universe began, but how it might all come to an end? It's a big question, one that scientists, philosophers, and dreamers have spent centuries trying to answer. But here's the twist: the universe's fate isn't just a scientific issue, it's deeply personal. After all, everything we are, our stories, hopes, and struggles, exists within this vast cosmic stage. And one day, that stage will collapse, freeze, or perhaps outright rip apart. Yes, you read that right. The same cosmos that gave birth to stars, galaxies, and even your very existence is destined for a dramatic ending. But how, exactly? The truth is so shocking, so counterintuitive, that it might make your head spin. Some theories suggest the universe could freeze into a lifeless void, while others argue it might tear itself apart down to the smallest atom. And then there's the possibility, perhaps the wildest of all, that everything reverses and collapses inward, erasing all we know, only to reinvent itself in unimaginable ways. The stakes? Only the very fabric of existence. If you think the idea of black holes melting into nothingness or galaxies breaking apart sounds surreal, imagine what scientists are uncovering as we speak. Spoiler alert, reality is even stranger than science fiction. But here's where things get fascinating. Buried within these cosmic mysteries are lessons that speak to us, even here on Earth. Lessons about time, purpose, and how fleeting everything truly is. Question is, are you ready to peer beyond the stars, dive into the science, and discover how the universe's inevitable finale might just hold clues about your own existence? If so, fasten your seatbelt, because the journey we're about to embark on is nothing short of extraordinary. And there you have it, Junior, the universe, with all its incomprehensible vastness, is heading toward an inevitable end. Whether it's an icy freeze, a violent rip, or an epic collapse into fiery oblivion, every possibility carries its own weight of wonder and mystery. But here's the real question: what will you do with this cosmic perspective? Does it make you feel small, or does it inspire you to make the most of your fleeting moment in this vast existence? After all, if even galaxies and stars have an expiration date, how are you spending your limited time under their glow? Are you burning bright, or simply letting your light fade unnoticed? So, tell us, what theory about the universe's end fascinates you the most? Is it the eerie stillness of the Big Freeze, the chaotic destruction of the Big Rip, or the fiery rebirth hinted at by the Big Crunch? Or perhaps you've got your own ideas about what lies ahead for matter, energy, and the very fabric of reality. We'd love to hear your thoughts. Drop a comment below and let's spark a conversation worthy of the stars. Who knows? Your theory might inspire someone else to see the universe in a whole new way. And before you go, make sure to hit that subscribe button and turn on notifications. There's so much more to explore about the universe, from its beginnings to its end, and we're just scratching the surface. Stick around, because the next big mystery we unravel together might just change how you see everything, both out there among the galaxies, and right here in your own life. Until next time, keep looking up.